Hospital-grade receptacles are required in specific areas within healthcare facilities to ensure electrical safety and reliability. Firstly, let's discuss patient care areas. These areas include operating rooms, critical care units, often abbreviated as ICU, post-anesthesia care units, often abbreviated as POCUs, emergency rooms, inpatient rooms and wards, neonatal intensive care units, often abbreviated as NICUs, and pediatric intensive care units, often abbreviated as PICUs. These locations demand hospital-grade receptacles due to the critical nature of patient care and the potential for life support equipment to be used. Secondly, we have critical support areas. This category encompasses areas such as the pharmacy, laboratory, sterile processing departments, blood banks, and biomedical engineering departments. These areas support patient care and require reliable power sources. Thirdly, there are other areas where hospital-grade receptacles are necessary. This includes any area where patient contact occurs, such as exam rooms and consultation rooms. Areas where medical equipment is used, such as nurse stations and treatment rooms, also fall into this category. Additionally, areas where conductive floors or grounded surfaces are present, such as operating rooms and medical imaging suites, require hospital-grade receptacles. This is also true for areas where explosions could occur, such as oxygen storage rooms. In areas where flammable anesthetics are used, such as operating rooms, special-purpose receptacles designed for such use are required. These receptacles are designed to prevent sparks that could ignite the flammable anesthetics. Receptacles in patient care areas should be located at least 20 inches, which is 508 millimeters above the floor or baseboard. This helps to prevent damage from spills and makes them more accessible. All receptacles should be ground fault circuit interrupter, often abbreviated as GFCI, protected to prevent electrical shock hazards. GFCI protection is crucial in patient care areas where moisture and electrical equipment are often present. The National Electrical Code, often abbreviated as NEC, Article 517 addresses healthcare facilities. This article provides specific requirements for electrical installations in these facilities, including the use of hospital-grade receptacles. The National Fire Protection Association, often abbreviated as NFPA 99, also covers healthcare facilities. NFPA 99 provides guidelines for healthcare facilities to minimize the hazards of fire, explosion, and electrical shock. Hospital-grade receptacles are designed to withstand the rigors of a healthcare environment and maintain a reliable electrical connection. They undergo rigorous testing to ensure they meet specific performance standards. These standards include durability, grounding reliability, and resistance to leakage current. The use of hospital-grade receptacles helps to ensure the safety of patients, staff, and visitors in healthcare facilities. Understanding the specific requirements for hospital-grade receptacles and their proper installation is essential for electrical professionals working in healthcare settings. This knowledge contributes to creating a safe and reliable electrical system that supports patient care. Let's elaborate on the specifications and requirements further. Hospital-grade receptacles differ from standard receptacles in several key aspects. Firstly, they are constructed with higher quality materials to withstand the demanding environment of healthcare facilities. The contacts within the receptacle are designed to provide a more secure and reliable connection, reducing the risk of power interruption. Secondly, hospital-grade receptacles undergo more stringent testing to ensure they meet specific performance standards. These tests include durability testing, grounding reliability testing, and leakage current testing. The durability test assesses the receptacle's ability to withstand repeated use and abuse. The grounding reliability test ensures that the receptacle provides a reliable ground connection to protect against electrical shock hazards. The leakage current test measures the amount of current that leaks from the receptacle to the ground. Hospital-grade receptacles are designed to minimize leakage current to reduce the risk of electrical shock. Thirdly, hospital-grade receptacles are typically identified by a green dot on the face of the receptacle. This green dot indicates that the receptacle meets the requirements for hospital-grade receptacles. In addition to the requirements for hospital-grade receptacles, the National Electrical Code, often abbreviated as NEC, also specifies requirements for the wiring and installation of electrical systems in healthcare facilities. For example, the NEC requires that all branch circuits serving patient care areas be provided with ground fault circuit interrupter, often abbreviated as GFCI, protection. GFCI protection is designed to detect ground faults and quickly interrupt the circuit to prevent electrical shock hazards. The NEC also specifies requirements for the grounding and bonding of electrical equipment in healthcare facilities. Proper grounding and bonding are essential to minimize the risk of electrical shock and fire hazards. Furthermore, the NEC requires that all electrical equipment used in patient care areas be listed and labeled for its intended use. This ensures that the equipment meets specific safety standards and is suitable for use in a healthcare environment. The National Fire Protection Association, often abbreviated as NFPA 99, provides additional guidance on the electrical safety in healthcare facilities. NFPA 99 covers a wide range of topics, including electrical systems, medical equipment, and emergency power systems. It is important for electrical professionals working in healthcare facilities to be familiar with both the NEC and NFPA 99. By following the requirements of these codes and standards, electrical professionals can help ensure the safety of patients, staff, and visitors in healthcare facilities. In summary, hospital-grade receptacles are required in specific areas within healthcare facilities to ensure electrical safety and reliability. These areas include patient care areas, critical support areas, and other areas where patient contact occurs or where medical equipment is used. Hospital-grade receptacles differ from standard receptacles in several key aspects, including their construction, testing, and identification. The National Electrical Code, often abbreviated as NEC, and the National Fire Protection Association, often abbreviated as NFPA 99, provide specific requirements and guidance on electrical safety in healthcare facilities. By following these requirements and guidelines, electrical professionals can help create a safe and reliable electrical system that supports patient care. Let's talk about specific examples. Consider an operating room. This is a critical patient care area where life support equipment is often used. Hospital-grade receptacles are essential in operating rooms to ensure a reliable power supply for this equipment. In a critical care unit, often abbreviated as ICU, patients are often connected to a variety of medical devices. Hospital-grade receptacles are needed to provide a stable and safe power source for these devices. In a neonatal intensive care unit, often abbreviated as NICU, premature infants require specialized medical care. Hospital-grade receptacles are important in NICUs to power the incubators, ventilators, and other medical equipment used to care for these vulnerable patients. In a pharmacy, medications are prepared and dispensed. Hospital-grade receptacles are needed to power the equipment used to prepare and store medications. In a laboratory, various tests are performed on patient samples. Hospital-grade receptacles are required to power the equipment used in these tests, such as centrifuges and microscopes. In a blood bank, blood and blood products are collected, processed, and stored. Hospital-grade receptacles are needed to power the refrigerators, freezers, and other equipment used in blood banks. In a biomedical engineering department, medical equipment is maintained and repaired. Hospital-grade receptacles are needed to power the test equipment and tools used by biomedical engineers. In exam rooms and consultation rooms, physicians examine and consult with patients. Hospital-grade receptacles are required to power the medical equipment used in these rooms, such as examination lights and diagnostic equipment. In nurse stations and treatment rooms, nurses provide patient care. Hospital-grade receptacles are needed to power the equipment used in these areas, such as infusion pumps and vital signs monitors. In areas where conductive flaws or grounded surfaces are present, such as operating rooms and medical imaging suites, hospital-grade receptacles are necessary to minimize the risk of electrical shock. In areas where explosions could occur, such as oxygen storage rooms, hospital-grade receptacles are required to prevent sparks that could ignite flammable materials. Let's discuss additional considerations for installing hospital-grade receptacles. Firstly, ensure that the receptacles are installed by qualified electrical professionals who are familiar with the requirements of the NEC and NFPA 99. Secondly, use only listed and labeled hospital-grade receptacles that meet the applicable standards. Thirdly, inspect the receptacles regularly to ensure they are in good condition and functioning properly. Fourthly, replace any damaged or worn receptacles immediately. Fifthly, provide ground fault circuit interrupter, often abbreviated as GFCI, protection for all receptacles serving patient care areas. Sixthly, locate receptacles at least 20 inches, which is 508 mm, above the floor or baseboard in patient care areas. Seventhly, use special purpose receptacles designed for use in areas where flammable anesthetics are used. Eighthly, properly ground and bond all electrical equipment in healthcare facilities. Ninthly, follow the manufacturer's instructions for installation and maintenance of hospital-grade receptacles. Tenthly, provide training to healthcare staff on the proper use and care of electrical equipment. Understanding the specific requirements for hospital-grade receptacles and their proper installation is essential for electrical professionals working in healthcare settings. By following these requirements and guidelines, electrical professionals can help create a safe and reliable electrical system that supports patient care and minimizes the risk of electrical hazards. Let's further discuss the code requirements specified in the National Electrical Code, often abbreviated as NEC Article 517. NEC Article 517 provides comprehensive guidelines for electrical installations in healthcare facilities. It covers various aspects, including wiring methods, grounding, overcurrent protection, and essential electrical systems. Article 517.10 addresses wiring methods. It specifies the types of wiring methods that are permitted in different areas of healthcare facilities. For example, it may require the use of rigid metal conduit or electrical metallic tubing in certain patient care areas to provide mechanical protection for the wiring. Article 517.13 addresses grounding. It requires that all metal enclosures and raceways be grounded to provide a low impedance path for fault current. This helps to prevent electrical shock hazards. Article 517.14 addresses leakage current. It specifies the maximum allowable leakage current for electrical equipment used in patient care areas. Minimizing leakage current is essential to reduce the risk of electrical shock. Article 517.16 addresses receptacles. It requires the use of hospital-grade receptacles in patient care areas. It also specifies the requirements for the location and spacing of receptacles. Article 517.25 addresses essential electrical systems. It requires that healthcare facilities have an essential electrical system to provide power to critical equipment and systems during a power outage. The essential electrical system typically includes generators, transfer switches, and distribution panels. The National Fire Protection Association, often abbreviated as NFPA 99, also provides guidance on electrical safety in healthcare facilities. NFPA 99 covers a wide range of topics, including electrical systems, medical equipment, and emergency power systems. It is important for electrical professionals working in healthcare facilities to be familiar with both the NEC and NFPA 99. These codes and standards are regularly updated to reflect the latest advancements in technology and safety practices. It is essential for electrical professionals to stay current with these updates to ensure they are providing the safest and most reliable electrical systems possible. Furthermore, consider ongoing training and education on electrical safety in healthcare facilities. Electrical professionals should participate in continuing education courses and workshops to stay up to date on the latest codes, standards, and best practices. Healthcare facilities should provide regular training to staff on the proper use and care of electrical equipment. This training should cover topics such as electrical safety, hazard awareness, and emergency procedures. Regular inspections and maintenance of electrical systems are crucial for ensuring continued safety and reliability. Healthcare facilities should implement a comprehensive electrical safety program that includes regular inspections, testing, and maintenance of electrical equipment and systems. By implementing these measures, healthcare facilities can help create a safe and reliable electrical environment for patients, staff, and visitors. Hospital-grade receptacles play a vital role in ensuring electrical safety in healthcare facilities. Their proper installation and maintenance are essential for protecting patients and staff from electrical hazards.